I'm going to go over a couple more examples of substitution. So any homogeneous equation, we're going to use this method of substitution where I want to make y equal to a variable times x, so I use u. Okay, so this is just one where you're trying to get everything to look like u equals y over x. So I'm like trying to get dy dx equal to a function of y over x. Okay, so here's an example. If we have this, okay, so here's an example that we would have. And what we could do is let's just get it into this form where dy dx equals something. Okay, so I'm gonna go dy dx equals negative x plus y, so I'm just bringing this to the other side. I divide it by dx and then divide by x, like that. Okay, if you notice, you could simplify this down to negative 1 plus y over x, and now you have it in that form that we are looking for. So I will have dy over dx equal to y over x minus 1. Okay, so from there I want to use these two things. Okay, well, it's one thing, it's one equation just written a different way. So, but I do want to get something. So right now on my right side I have u minus 1 based on that equation because it's y over x. Now here I'm going to use this to find out, well, if I'm doing the substitution with u, I have to have u in the problem. So if I take the derivative with respect to x, I'll get u plus x du over dx. Okay, so let's substitute there. U plus x du over dx. And now I have the two variables that I want. Let's see what happens if I subtract u to both sides, right? Subtract u to both sides. I get du over dx equals, well, that's going to cancel. I get negative 1. And now what we could do is separate and integrate. So here you could see that I'll have du equals negative dx over x. Okay, so at this point now just integrate, which in our here I would get u equals negative ln absolute value x plus c. And when you're doing these problems, you can't leave it that way, even though you did solve and find a solution, but you want to get it back into terms of x and y. So I got to go back to say, okay, u is y over x. So I have y over x equals negative ln x plus c. So y equals negative x ln absolute value of x plus c if I multiply both sides by x, and then cx as well. Don't forget that cx. Okay. All right. So that's an example of substitution. I could do another one here. Let's do another substitution because it's good with practicing your separating and integrating. So let's say I have x dx plus y minus 2x dx equals 0. Okay, let's say we have this one. All right, oh, that should be dy. Okay, equals 0. All right, so let's get this divide by. So I'm going to have dy over dx equals negative x over y minus 2x. like that. All right, so again, we want to use, I'm just going to scroll back up, we want to use this, y is equal to some variable times x, right? So y is equal to ux, all right, and then we know u is equal to y over x. So let's get this to look like a function of y over x. So I'm going to divide everything by x. So I get dy over dx equals -1 over y over x minus 2. Okay, so now I could simplify that with a u, but if I'm going to do this simplifying, I have to take the derivative of that highlighted function with respect to x. So I get dy dx equals u plus x du over dx. So I'll have u plus x du over dx. So now I'm substituting in, right, our u and our differential right here and here. So I have -1 over u minus 2. And now let's solve. So I'm going to subtract u to both sides. Okay, and here then you could see that this is going to be common denominator, right? So du over dx equals -1 minus u times u minus 2 over u minus 2. And we would get -u squared plus 2u all over u minus 2, like this. All right, now from here, we could separate and integrate from here. So I'm just gonna like do the reciprocal of the fraction here. I'm gonna rearrange some things, bring out a negative, and put this as u squared minus 2u plus 1 and du, and then that's going to equal dx over x. Okay, so next step is, let's see if we could simplify this side to make it easier for us. So I could get u plus, actually it's going to be u minus 1 squared du equals dx over x. All right. All right, so when we are simplifying this, we could do a couple things. If you have repeating, so factors, right? So you're gonna have u minus 2 over, I'm gonna kick this negative, let's bring this negative over to the other side, just so I don't have to deal with it. Let's put it over there. So you have two repeating factors, meaning that you could have a factor by itself plus a factor squared this way, okay? Now there's still going to be a and b, okay? So what we'll have here is, in order to solve this, you still will do a common denominator, so it's gonna be a times the u minus 1, but b is left alone. So we can solve for b. If you make u equal to 1, right, you would get -1 is equal to b. But solving now for b is a little bit tougher. So what you could do is just try to match things up. So I would have a u minus a plus b, right? And if you could see, two things are going to happen, right? We know a is going to be 1 just based on the coefficient in front of u, okay? So you know that, like here, if I make a equal to 1, right, a is going to equal 1, that means -a plus b has to equal -2, which makes sense because we got b to be -1. All right, now the reason why I did that is because now we can do an integral a lot easier for this left side. Okay, so here I'll have 1 over, because a was 1, over u minus 1, and then minus b was negative 1, so it's minus u minus 1 squared. Okay, and you'll see now we could integrate both sides, separate, integrate, right? And here you would then get ln u minus 1 minus, so this is antiderivative, right? So this is going to be plus 1 over u minus 1, and then equals negative ln of x plus c. And now we have to substitute back in our y over x. So we have y over x minus 1 plus 1 over y over x minus 1 equals negative ln of x plus c. You could do a couple things simplifying, right? If you add ln x to both sides, right, ln x to both sides, what you could do is it'll cancel out on this side, giving us c here, and then this is a multiplication property inside because you're adding two natural logs together. So I'm going to get ln of y minus x, and then I could do, simplifying this complex fraction, multiply everything by x, and you get plus x over y minus x, just so that it looks a little cleaned up. Okay? All right.